LTM is an innovative tunneling method in which drilling and blasting for enlargement of the pilot tunnel, as well as construction of the concrete lining, can be carried out simultaneously during the excavation of the pilot tunnel by the TBM. Tunnel construction can be completed in the shortest period, whereas in conventional methods, the blasting for enlargement is possible only after the pilot tunnel is passed through. Therefore, the period can be reduced by 30% or more, and costs can be reduced by 10% or more due to the reduction of loosened area around the tunnel face. In existing methods, the loosened area around a face increases during blasting, since charge holes are drilled longitudinally. Whereas in LTM, the major direction of crack propagation due to blasting is changed to the front of the face. Therefore, the loosened area around a face can be reduced considerably. Rock supporting materials such as shotcrete and rock bolts are minimized, and vibration and noise at ground surface can be reduced significantly. In LTM, besides the tunneling method, the drilling equipment which can drill the blasting holes in an oblique direction, the carrier which rapidly disposes of muck generated from the blasting for enlargement, the mobile ladder, and so on are all included. The carriers are categorized in the bottom carrier, the deck plate carrier, and the ladder carrier, besides the main carrier which can load a large amount of muck. Accidents due to derailment can be prevented by the subsidiary wheels close to the main ones. Moreover, excavation by the TBM, blasting for enlargement, and construction of lining are possible simultaneously by moving equipment required for the TBM, such as electricity supply cables, onto the rail system and protecting them with the carrier. Reviewing the progress of the LTM, first, the jumbo drill mounted on the backup trailer of the TBM drills the oblique blasting holes in advance at the upper half section of the tunnel simultaneously with the TBM excavation. At the same time, the muck generated from that is loaded on the trolley through the conveyor belt disposed to the side of the pilot tunnel. When the oblique blasting holes have already been drilled in the pilot tunnel, the upper and lower half section of the tunnel are connected by the mobile ladder. Then the jumbo drill moves to the upper half section of the tunnel using the ladder. The jumbo drill, having moved to the upper half section, drills only the outermost tunneling section on the deck plate carrier. As the drilling work either on the left or right side of the tunnel is finished, the jumbo drill continues the drilling work on the other side. After finishing the drilling work on the upper half section, the jumbo drill moves down to the lower half section using the ladder. Then the ladder moves to the rear of the tunnel face and downs the front ladder to the ground to get the jumbo drill to start the drilling work at the lower half section. After finishing the drilling work, charging the blasting powder and sand stemming can be carried out at respective blasting holes using the working car. Finally, the carriers are disposed suitably, and the blasting work can be prepared by decoupling the ventilation duct for the TBM. At the same time, all workers and equipment, including the TBM operators, are evacuated, and the blasting is carried out simultaneously both at the upper and the lower half sections. Ventilation is carried out after the blasting. Then the side loader can enter the upper half section to remove the muck. The muck removal work can be done rapidly by moving the empty carriers near to the tunnel face using a winch after removing the ladder. As soon as disposal of the muck is finished at one side of the tunnel face, the decoupled ventilation duct for the TBM is coupled again, and TBM excavation can be continued. Next, the loader moves to the other side and finishes the removal of the muck in the upper half section. Then, the arrangement of the surface of the lower half section to install the ladder becomes necessary. In this case, another loader in a neighboring tunnel can be used additionally through the transverse shaft. On the other hand, the carrier filled with muck is pulled out of the tunnel at the same time, Empty main carriers are brought to the face to load the muck in the lower half section. At this moment, the jumbo drill moves up to the upper half section and carries out the drilling of blasting holes at the outermost tunneling section. And then the loader moves to dispose of the muck at the lower half section. As the muck removal in one side of the lower half section is finished, the loader moves to the other side and removes the rest of the muck. At this moment, the jumbo drill, having finished the drilling work on the upper half section, moves down to the lower half section and carries out the drilling work at the one side. After finishing the removal of muck at the other side, the jumbo drill moves to that side and finishes the drilling work at the lower half section. On the other hand, as the muck removal work is finished at the lower half section, the carriers filled with muck are pulled out of the tunnel, and after the mixer truck for shotcreting enters the tunnel, being mounted on the bottom carrier connected to the deck plate carrier and the ladder carrier, the work of shotcreting and rock bolting is carried out. At this time, the trolley for the TBM to be taken out of the tunnel should pass through the section of blasting for enlargement. But because the work of shotcreting at the upper half section can be done at the same time, the loss of cycle time can be minimized. On the other hand, the construction of lining is carried out simultaneously at the rear part several hundred meters distant from the face for enlargement. The ventilation duct for the TBM or NATM can be hung by bolts, using the space between the segments, and the rail for the lining form can be installed by crane on the bottom carrier. In addition to this, an emergency resulting from a malfunction of major equipment can be overcome by securing the space for passing through them, using the traveler of the lining form in which the height can be controlled by the hydraulic system if necessary. After finishing the TBM excavation and the blasting for enlargement, all facilities related to the TBM excavation are dismantled sequentially, and the transverse blasting on the lower half section of the center of the tunnel can be performed. At this time, the lining can be protected from the blasting by installing the steel shell composed of several segments. On the other hand, the disposal of water from the TBM and underground can be guided to the drainage on the surface of the tunnel by drilling holes transversely on the lower half section of the center of the tunnel. The California switching system could be installed to 3 lanes by utilizing the enlarged final section of the tunnel. Therefore, it can help the trolleys for the TBM and the carriers to move freely, and the carriers moving out of the tunnel can be used effectively in small sites by applying the dumping system. Now, comparing economy between LTM and existing methods in the case of a general twin tunnel with 2 lanes, it is estimated that the reduction of the construction period becomes evident from the length of 1 kilometer, and is reduced by 5 months at a length of 2.5 kilometers, and as much as 15 months or more at a length of 5 kilometers. Consequently, the period can be reduced by 30% or more. It is also analyzed that the construction cost is the same as that of existing methods at a length of 1 kilometer, but that savings appear at a length of 1.5 kilometers. Consequently, costs can be reduced by 10% or more. Therefore, the LTM can be applied effectively in the long tunnel with a length of 1 kilometer or more.